Welcome and study with Tanzania Institute of Education.
Welcome student to our chemistry session. My name is Madam Jennifer Kaizilege. We are going to learn about the volumetric analysis today. Volumetric analysis, by definition, is the process of determining the amount of a substance in terms of volume and the concentration of the reacting substance. So today, our aim is to determine concentration of the reacting substance. Then before we go to determine the concentration of the reacting substance, we need to ask ourselves, what is the meaning of concentration? So concentration is the amount of a substance, and when we talk about the amount of a substance, we refer a number of moles. Amount of a substance or the mass of a substance dissolved in a liter of a solution. When you talk about the amount or when you talk about the mass, it must be the mass of a solute. And when you talk about the volume of the solution, it must be the solvent. So that is when the solute and the solvent react together, we form what we call a solution. And concentration are of two types. There are two types of concentration. There are two types of concentration. Number one, it is called the mass concentration. Mass concentration. And the number two, it is called the molar concentration or molarity. Molar concentration or molarity. Let us discuss one type after another and see how we can calculate each type of concentration. Now let us start with the mass concentration. Mass concentration. Anything concerning with mass, it must be in the SI unit of gram. Therefore, mass concentration is the mass of a solute dissolved in a liter of solvent. Is the mass of a solute dissolved in a liter of solvent. Mass of a solute dissolved in a liter of solvent. And since it is a mass of a solute dissolved in a liter of solvent, therefore, what is the formula used to calculate the mass concentration? Let us see the formula used to calculate the mass concentration. What are these? We know that mathematically, mass concentration will be given by mass of a solute in gram, mass of solute in gram, divided by the volume of a solution in decimeter cubic, divided by volume of solution in decimeter cubic, So from this division, what does it mean? From this division, we are going to construct the SI unit of mass concentration. From the division, we are going to construct the SI unit of mass concentration, and therefore, since the mass is measured in a gram, and the volume is measured in decimeter cubic, therefore, the SI unit of mass concentration is gram per decimeter cubic. So, the SI unit of mass concentration, we abbreviate as CO, and C is gram per decimeter cubic or grams per liter. Gram per decimeter cubic or grams per liter. So we can calculate the concentration of a given solution if the mass of the solution is known and the volume also is given. We can calculate the mass concentration of a given solution if the mass is given as well as the volume is provided. Let us see simple example. Let us see simple example. Calculate the concentration of the following. Calculate the concentration of the following solution. Calculate the concentration. Number 1, calculate the concentration of the following solution. A, you are provided with the 10 grams of a solute dissolved in 400 cc of a solution. You are given 10 grams of sodium hydroxide dissolved in 400 centimeter cubic of a solution. So you are supposed to find the mass concentration. You are supposed to find the mass concentration. In chemistry, you cannot calculate the mass concentration or anything that you're supposed to calculate. First, you have to identify the data which is provided. Then, if you go back to our question, we have to read and identify what has been provided and what are we supposed to calculate. So, from the question, it is given that there is 10 grams of sodium hydroxide. That means sodium hydroxide were acting as a solute. This one were dissolved in 400 centimeter cubic of a solution. But this 400 centimeter cubic must be converted into decimeter cubic. Why? Because we don't have the SI unity which is measured in gram per centimeter cubic. Therefore, we go for solution. Data given. What are we given? Data given. We are given the mass as 10 grams. We are given the volume as 400 centimeter cubic. This one, if you convert into decimeter cubic, you are going to get 0.4 decimeter cubic. You're going to get 0.4 decimeter cubic. Some, they will ask themselves, where did 0.4 come from? Where did 0.4 come from? This is how 0.4 is obtained. This is how 0.4 is obtained. We know that 1 decimeter cubic is equal to 1,000 centimeter cubic. 1 decimeter cubic is equal to 1,000 centimeter cubic. Then from our question, what has been given? We are given 400 centimeter cubic. We are given 400 centimeter cubic. Then what about this 400 centimeter cubic in decimeter cubic? Then in mathematics, you are supposed to cross multiplication. If you cross multiplication, then x will be equal to 1 decimeter cubic times 400 centimeter cubic divided by 1,000 centimeter cubic. So the answer will be equal to 0.4 decimeter cubic. This is where 0.4 is obtained. But I was just reminding you and see how do we convert centimeter cubic into decimeter cubic. Now we can proceed with our requirement. We are supposed to find the mass concentration. Now we have the data, that is mass, and we are also given the volume. What next is to find the formula on how to calculate the mass concentration. Therefore, from our formula that we have been discussed earlier, or we have derived earlier, it is concentration. We use CONC as an abbreviation. this is equal to the mass of a solute in a gram, mass of solute, the mass of solute in a gram, mass of solute in a gram, divided by the volume of solution in decimeter cubic. Therefore, what is the mass? What is the mass class? The mass is 10 gram. This is 10 gram divided by what is the volume? The volume is given as 0.4 decimeter cubic. 0.4 decimeter cubic. Then using your calculator, I know you are allowed to use the calculator. Then if you take 10 divided by 0.4, in mathematics you can remove the decimal places by multiplying by 10 in each side, which is equal to 100 over 4. This is 100 gram over 4 decimeter cubic. And then what is the answer? 100 divided by 4, the answer is 25. The answer is 25. This is 25 grams per decimeter cubic. So this is the concentration which is obtained when 10 gram of sodium hydroxide will be dissolved in 400 centimeter cubic. This is the concentration that will be obtained when you take 400 gram, 10 gram of a solute sodium hydroxide, dissolving it into 400 centimeter cubic. That is type number 1, known as mass concentration. Now let's go for number 2, which is called the molar concentration, or in the other language it is called the molarity. Molar concentration or molarity. Then what is molar concentration? Molar concentration or molarity, this is the amount of a solute dissolved in a liter of solvent. Amount of a solute. Some people may be asking themselves, amount. When you talk about amount, you will refer to the number of moles, mind you. So, number 2, it is molar concentration or molarity. Molar concentration or molarity. But common language or common, it is molarity. As per definition, it is the amount of a solute, dissolved in 1 liter of a solution. Amount of a solute dissolved in 1 liter of a solution is the amount of a solute dissolved in a liter of solution. That is the definition of molarity or molar concentration. So since it is amount of a solute dissolved in a liter of a solution, we are going also to find a formula on how to calculate molarity. And from the formula, we are going to have the SI unity of molarity. So keep on following and see how are we going to derive the formula on how to calculate molarity. Therefore, we know that molarity, I'll be using molarity instead of molar concentration. This molar concentration, that is the one which derive molarity. This is equal to amount of a solute, number of moles of a solute, number of moles, that is amount of a solute, number of moles, divided by the volume of a solution, volume of solution. So this is a formula that you'll be using to calculate the molarity. Number of moles divided by volume of a solution. Let us see the symbols that we can use in order to find the molarity. Molarity is abbreviated as M, capital M. Number of moles is abbreviated as small n. and the volume of a solution will be abbreviated as V. So to calculate molarity, I must be given the number of moles of a solute and the volume of a solvent. To calculate molarity of a substance or molar concentration, I must be given the number of moles and the volume of a solution. Therefore, what is the SI unit of moles? What the SI unit of the amount of a solution? It is moles. This one is measured in moles, and this one is measured in decimeter cubic or liter. Therefore, from the SI unit, we can now develop from these units, we can now develop the SI unit of molarity. Therefore, SI unit of molarity is moles per decimeter cubic or moles per liter. That is the SI unit of molarity. Remember, chemistry is a unity. There is no any value without unity. So we must insist on how to find the SI unit for every substance that you are required to calculate. Let's now go for examples. We are going for examples. But before we go for examples, there's another formula we can develop from this formula. Before we touch examples, there's another formula which we can develop from the molarity is equal to number of moles over volume. Now let us see how can we develop another formula, and then we'll see more examples on how to calculate molarity. We know that from molarity is equal to number of moles over volume. But we can define number of moles, refer to mole concept. We can define number of moles. How do we calculate moles in mole concept topic? I hope that your teacher taught you that number of moles is equal to mass of a substance given, mass given, that is mass of a solute, mass given over molar mass. Molar mass. So N equals to small m over mR, where mR stands for molar mass of a substance. Therefore, since I know N is equal to m over mR, I can substitute this formula. Instead of writing N here, I can write m over mR. Therefore, molarity also can be calculated by mass of a substance over volume times the molar mass. I guess in mathematics this is correct. In mathematics this is correct. Therefore, mass over volume times 1 over mR, it is still correct, because if I take mass over volume times 1 over molar mass is similar as mass over volume times molar mass. Therefore, what is mass over volume? It is mass concentration. Mass over volume, this one represent concentration. Therefore, mass over volume, this is same as mass concentration. This is same as mass concentration. Therefore, I can say molarity also can be given by taking mass concentration, this is measured in a gram per decimeter cubic, divided by the molar mass of a substance. Molar mass of a substance. This is also another formula of calculating the molarity of a given substance. This is also another formula which you can apply when you want to calculate the molarity in case you are given the concentration of a substance and the molar mass of that substance again. So let's go for example. Calculate the molarity of the following solution. Number 1, calculate the molarity of the following. A, it is calculate the molarity of the following. A, 2 gram of potassium hydroxide in 2 liters. So you're supposed to calculate the molarity of potassium hydroxide, which is containing 2 grams, and these 2 grams of potassium hydroxide were dissolved into 2 liters of a solution. And how are we going to calculate it? Then we go for solution. We are given mass, which is equal to 2 grams. We are given the volume, which is equal to 2 liters. Then what is required? It is molarity. It is molarity. Therefore, we know that molarity is equal to concentration in grams per decimeter cubic divided by what? Divided by molar mass. But see, we don't have the concentration. We don't have the concentration, but from the data given, we are going to calculate the concentration because we have the mass and we have the volume, and therefore, molarity can also be given as concentration is equal to mass over volume. Okay, mass over volume divided by molar mass. Then what is mass over volume? We can first calculate mass over volume, or we can apply the formula direct. But let us find the first mass over volume. What is this? The mass we are given as 2 grams, the volume we are given. The mass was given as 2 grams, the volume we are given as 2 liters. So the answer is 1 grams per liter. This is the concentration. And what is the molar mass of potassium hydroxide? Molar mass of potassium hydroxide. Molar masses. You can refer to Form 2 topic, but now let us remind you how do we find the molar mass. Potassium hydroxide, this one can be calculated. The atomic mass of potassium, it is 39, then plus the atomic mass of oxygen, it is 16, the atomic mass of hydrogen, it is 1. So this one, it is 39 plus 16 plus 1. 39 plus 16 makes 40, 55, then plus 1 makes 56. So this one is equal to 56 grams per mole. And since we have the molar mass and we have concentration, now we can plug the numbers in molarity. Therefore, molarity is equal to what is concentration? 1 gram per liter divided by the molar mass, it is 56 gram per mole. So this one, it has to be the unity, gram and gram will cancel. These moles will come up liter will remain down, the SI unit will be moles per liter. So if you compute in your calculator, the value that you're going to get will be the molarity. Now you can use your calculator and try to compute the value of molarity. You can use your calculator, try to compute the value of molarity. So now let me give some simple examples so that now you can try at home, and by consulting different books, especially this from Thai, you can also get more examples about molarity and the mass concentration. From there, we'll be able to proceed with another subtopic. Let me write a very simple exercises for you. Let me write simple exercises for you. Okay, now exercise, try this. Exercise number 1, calculate the mass concentration of A. This is 0.05 moles in 80 centimeter cubic. I'm going to leave you with only one question. Try to do it, and I guess everyone will be able to compute the mass concentration. Refer to your notes, refer for what we have been discussing, and from there, for today, our topic is over. Thanks very much for listening. I hope we are going to meet the next time.
Let's study, be educated, elimu ni kazi. Elimu ni kazi. Learn, let's study, be educated, elimu